To demonstrate Mediaflux real-time, we'll be using OBS Studio to initiate a recording to the path Private Mount Real-Time. On this system, Private Mount Real-Time is mapped to the Mediaflux Real-Time export. In the centre panel, you'll see the representation of the underlying storage from the receiving Mediaflux Real-Time server. This is NFS1. On the right-hand pane, we have the corresponding view from the second remote real-time server, NFS2. When we start a recording, you'll notice that files appear instantly in both Premiere workstations, the local and the remote. If we drag these into VLC, you'll see playback begin immediately on both sides, and as the video continues, the files grow in real time. This is reflected by the progress marker occasionally jumping back as more data is added. We've just played out, not from a real-time mount, but directly from the synchronized underlying storage. Latency and time to edit are of paramount importance when replicating data in the media and entertainment industry. So we built real-time to allow reads directly from the underlying storage, ensuring zero latency overhead for playout and editing operations. Switching to Premiere, dragging the files onto the timeline shows they're both approximately the same length. In fact, since there was a slight delay on my end, the second remote version is slightly longer. You can scrub through these files as you normally would. Because the files are actively growing, we can continue to extend the timeline. On the second site, the same functionality applies. We can hit play, scrub through, and extend the file to the new edge of the growing video. Playback continues smoothly, and as we scrub and extend further, you'll see both timelines growing in sync. Again, we performed editing directly from the underlying storage, so that your editors can work in real time with incoming feeds, speeding close to the latency asymptote of the speed of light times distance. You can see in this diagram how Mediaflux Real-Time synchronizes incoming feeds at multiple sites, while allowing latency-sensitive read actions to occur directly from the underlying storage.